Before we get started, I want you to listen to this song. Pay attention to what you hear, and I'll ask you about it afterwards. What different instruments did you hear? What about the sound produced allowed you to identify those instruments? My name is Parth, and I'm with the RPI Engineering Ambassadors. Throughout this video, I'll explain how digital sound works. I'll begin by talking about the properties of sound, how sounds in music are stored, how that stored sound is produced, and digital sound's applications in advanced engineering. We'll begin with its properties. Sound is a wave, and all waves have two important properties: frequency and amplitude. Frequency refers to how quickly the wave completes one full cycle. For example, this 4 Hz wave completes 4 cycles per second. The greater the frequency of sound, the higher its pitch. Amplitude refers to how tall the wave is. It tells us how much energy a wave has. The greater the amplitude, the louder the sound. Changing both the frequency and amplitude of a sound wave creates all the different sounds. A guitar note has a waveform different than a cymbal crash. Now, let's move on to how these different waveforms can be stored in digital devices. Engineers use numerical data to store sounds. Specifically, they use binary, a combination of ones and zeros, or ons and offs. Combining ones and zeros lets us get even larger or much smaller numbers. This process is similar to how Morse encodes letters. Think about how many songs fit on your phone. Now, how many fit on a CD? What do you think accounts for the difference? The answer is a technique called digital compression. One kind of compression software uses thresholds. Any amplitude or frequency above the given threshold is removed from the data, allowing for large files to be cut down. This technique has one clear drawback. It can eliminate potentially important data. Take a look at what happens when an image is highly compressed. Here, the threshold was set too low, and too much information was lost. The same thing can happen in an audio file, corrupting the sound quality. To combat this, engineers use more precise threshold management, and many compression software apply an understanding of the limitations of human hearing to filter out unnecessary data. Something similar was done in the JPEG picture encoding, resulting in minimal differences between the smaller compressed file and the original. Applying advanced compression software to music allows us to store thousands of songs on a small device. Compression is a software technique, but what about improvements to the devices themselves? Smaller and smaller chips and storage units have allowed computers to evolve from the behemoths used by the US military in the 1940s to the laptops used everywhere today. Computer and materials engineers have worked together to create these efficient devices. Now that digital sound has been stored, the next step is to produce it. Sound players have to take the stored binary data and convert it to electrical impulses. These electrical impulses have the same frequency as the desired sound and the same amplitude pattern. So how do speakers produce sound? The sound waves we've been talking about are vibrations of molecules in the air. So to create sound, our speakers need to be able to vibrate air at the desired frequency and with the desired energy. So how do these speakers work? To get into that, first we have to talk about electromagnets. An electromagnet is created using a coil of wire. As you might know, electricity results from the movement of negative charges, electrons. When electrons move in a loop, they produce a magnetic field. We can make our own electromagnet with a battery connected to some copper wire, producing a magnetic field. Unlike a permanent magnet, which is always producing a field, an electromagnet only produces a field with electricity, and when we turn the battery around, the field reverses. Magnets attract each other when the North Pole meets the South Pole, and repel when two of the same poles meet. By switching the magnetic field of our temporary electromagnet with the right frequency, we can move a permanent magnet with the same frequency as well. If we attach the magnet to the cone, the movements are transferred to the air, creating sound. So now that we can produce it, where else can engineers use digital sound other than speakers? One property of waves that engineers use is interference. Combining two different waves creates a third wave, which is the sum of the two. If the two waves being added are perfectly aligned, they will enhance each other. This is called constructive interference. If they are out of alignment, they will cancel out. This is called destructive interference. Engineers use constructive interference to amplify sounds for hearing aids and destructive interference to quiet sounds in noise-canceling headphones. Specialized speakers, microphones, and other audio systems are everywhere, from emergency equipment to aviation and in concerts and stages. Engineers are also developing new software to create, amplify, and edit sounds. Digital sound and audio engineering impact our everyday lives, whether it's to help with the little things like playing a song to lighten the mood, or the big things like helping those with hearing disabilities. Thank you. So now I'm going to be presenting the hands-on portion for the digital sound presentation. In order to do this activity, you're going to need some materials, and I'll just go through what you'll need to make each individual speaker, which is what the activity is. So I guess for the whole class set, you'll need a string of copper wire. The best wire to use, in my opinion, is one that's kind of thin. It needs to be insulated, but the thinner it is, the better the magnets will be, and it's easier to strip at the end, so you don't have to use anything like a wire stripper. And of course, you should have some scissors to cut the wire with. So like I mentioned in the presentation, the way a speaker works is it's a temporary magnet wrapped around a permanent magnet. So you're going to need a permanent magnet right here. The ones I really like to use are these small discs. They're these disc magnets, and the flat parts are the north and south pole, and it's important to know that later on. You'll need some sandpaper to strip off the ends of the copper wire, and some tape to hold everything together. Additionally, for each single speaker you make, you're going to need some kind of plastic cup. The cups are really good because they can amplify the sound, so you put it right up next to your ear, and you can really hear what the magnet's producing. In order to connect your whole circuit together, you're going to need 2 alligator clips per speaker you're going to make. And for each student that's going to be participating in this, you'll need an auxiliary cable, these 3.5mm jack cables that you can plug into a phone or MP3 player. All right, so let's get started. So the first thing you want to do is take the copper wire you have and get about an arm span's length of it. The exact length isn't important, just make sure it's long enough so you don't run out of wire halfway through. And you want to take the 2 ends of it and take the sandpaper and just kind of roughly rub it across it just so the insulation is removed, and you should be left with this shiny copper gold looking thing underneath. And so you want to make sure you're doing this on both sides, but not in the middle of it. The middle has to stay insulated. That's the only way we can get a good temporary magnet, is that the metal part actually isn't touching itself. So make sure you just have a decent area where it's copper exposed, and you're all good to go there. So you won't need these for a while. Now take your permanent magnet. Again, make sure you know which sides are north and south. So for, again, these disc ones, north and south are the flat ones, and make sure they're facing up and down. And so what you want to do, and this is kind of difficult, and it took me a bit of practice, is to take the center of the copper wire and just try to wrap it around as many times as you can around this permanent magnet. And so, yeah, the first loop is really hard to get on just because it really likes to move. Once you've got a couple on there, it becomes a bit easier. And so one of the rules of electricity and magnetism is that if you're trying to make a temporary magnet, the magnet's going to be stronger the more windings you have. So really try to get as many coils as you can fit in that small area, and you'll get louder speakers. If you find that once you've done this activity and you've plugged it all in, you're not hearing anything or it's really quiet, one of the issues might be is you don't have a strong enough temporary magnet. So go back to this step and see if you can squeeze in some more windings into your design. Okay, so now that you've formed a good enough coil, again, the problem is this wire really likes to slip on the magnet. So immediately take your plastic cup and set it face down so the opening is pointing down, and just lay your magnet right in the center on the top of that plastic cup. Then take some amount of tape that you've set aside, or just ask one of your partners that you're working with to help you out on this, and just stick it down. Use the sides of the cup and just tape that magnet down to the surface as best you can. Then what you want to do is take a bit more tape and put it kind of like a cross on the top, just so it really stays in place. And now you've pretty much got your speaker set up. You've got the magnet in the middle and the cone to amplify the sound, and now you have to hook it up to something that's actually going to play your music. So let's revisit these strippings that we made at the end of them. And what you want to do is take your 2 alligator clips and set one for each side. So clip one end of the alligator clip to a part where that copper is exposed, and then do the same thing on the other side. Make sure that there's a good connection, and now you have to hook it up to that 3.5mm auxiliary cable so the sound can be transmitted from your phone into the speaker. And so there are many different kinds of these auxiliary cables. This is actually a bit of an older model, but on our Reach website we have a picture that shows what some of the new models are and what each section means. But you'll see in this one it has a single divider in the center, which means there's a top part and a bottom part to it, and it's important to know what these parts are. So for this one, the top part is where the signal's coming from, and the bottom part is a ground. And in the circuit, you need to go from the signal to the ground, and so that's what we're going to do with these alligator clips. So it really doesn't matter which end you want to choose, but take one end and clip it to the top half above that black divider, and take the other end and clip it to the bottom half below the black divider. And so now you've completed your circuit on your speaker end, and all you have to do is plug the other end into something like your phone. So take like the small 3.5mm jack on the bottom, plug it in. Again, this is a really weak speaker, so make sure you can turn your volume up as high as possible and play whatever song you'd like to, and you can hear it play, and I think it's really cool sounding. Another thing you can do is most times when you guys buy headphones or speakers, there's two of them. One usually corresponds to a left and a right. So if you want to partner up with one of your friends or just make two of them yourself, take another set of speakers, and you can also connect those to the auxiliary cable to get one in the left ear and one in the right ear. Like I said, some of these new cables have multiple dividers, so make sure you look up what kind of cable you have, and make sure both of them have one end that goes to the ground. So take one, so on your second speaker, have one exposed end go to the same ground as the first speaker, but make sure the other end goes to either the left and the other one goes to the right. So they should be on different signal sections, and that way one ear is listening to the left side of the music, one ear is listening to the right side, and you can get much better sound quality that way. So give it a try. Hope you guys enjoy the video. Thank you for watching, and check out more on the Reach site if you're interested in what we do.